All right, this is Module 8, Part 2. We are going to talk about the second standard. I can apply relationships between arcs and angles. So our first theorem is if it's on the circle. So we have arcs and angles. If your tangent and a chord intersect on a circle, then your angle equals 1/2 the arc. Now this is very similar to our inscribed angle that we just learned about last video. So it's going to be the same concept, and it kind of looks even the same because your vertex is on the circle. So your angle, you always start with your angle. So the measure of angle 1 equals 1/2, and then the arc. So it always has to match up. So your arc has to match up with that angle, which it does, so then it's 132. So the measure of angle 1 is 66. Okay, part B. So I want to find the measure of EFD. EFD, so this arc right here. So we're going to set it up the same way. You always start with your angle. So 110 equals 1/2 the measure of EFD. So in order to get rid of that 1/2, we divide by 1/2. Which, if you remember in the last video, is the same as multiplying by 2. So the measure of EFD is 220. Alright, you try this one and find the measure of AB. Now this one's a little trickier because you have to find this arc. See if you can use some brain power and try to work that out. Good luck. Alright, so this is how I solved it. There's another way we could do it, but if I know my angle is 120, I know the arc is 1/2 times the arc equals the angle. So I set that up in green, and I found my arc was 240 degrees. Now, after you know it's 240, I know all the way around a circle is 360. So I just subtracted the two to get what's left, which is 120, and I'm done. Now another way I could have done that is I could have found this angle, because this whole thing is a straight line, so that means it's 180, so that means this is 60. So I could have said 60 equals 1/2 the measure of AB, which then would give me the measure of arc AB would be 120. So you get the same answer. This is just an alternative way. Otherwise, you could do it in blue and green. Okay, so here's some more theorems. So that was when it's on the circle. This is now when it's inside a circle. We are going to add your arcs. So if you have an angle, like angle 1, you're going to add the two arcs that match up with that, which is the intercepted arc, intercepted by the angle, and its vertical angle. So if I know that angle 1 is there, the vertical angle, and then their arcs, we add up. 2, it would be the other two arcs. So if I look at this angle, it would be this angle, and then it would be these two arcs. So the last one, if it's outside a circle, you subtract your arcs. And the biggest thing to remember, and they're all the same, they just look differently, you want to do your bigger arc minus the smaller arc, because we don't want any negative arcs. And I have this all written down at a simpler form in the later slide. Okay, so this one, we have a couple vocab words so you understand the theorems. Segments of a chord. So if I have two chords intersecting inside a circle, it divides it into two segments, which is the segments of a chord. So this right here and this right here are your two segments of the chord. So the biggest thing to remember is that the segments of a chord are in the same chord. This one too. So this one, the yellow and the red match up. They are segments of a chord. A secant segment would be the whole thing right here. The external segment is just the outside portion. So this right here is your external segment. The whole piece is your secant segment. Okay? And then your tangent segment is just a segment that's tangent to the circle. So that one's pretty easy. All right, so when it's inside a circle, it's going to be part times part equals part times part. So this is where your segments of a chord come into play. So this one segment and this one segment. So they match up, blue, to that one segment. ED and then EC. So the biggest part is this is one segment and this is one segment. All right, now this theorem is your secant theorem. So if you have two secants, you are going to do your outer piece, that's this right here, times the whole piece, and that's this. So the outer piece times the whole piece. And actually I'm going to say the same thing for this one. Even though the theorem states a little bit differently, I think it's a little easier if I just do out times whole all the time. So out times whole, the outer piece is the whole piece on this case. So that is why EA times EA. So in that case, if it's a tangent, your out equals the whole. Now EC is the outer piece, and ED is the whole piece. So, putting it all into a very easy 5 different formulas, I would pause the video and write these down in your notes if you did not print out your notes. Otherwise, make sure that you refer back to this, because this is going to be huge for when you're going through the different problems. And just making sure you know on, outside, or inside, inside, and outside. So just making sure that you match up the different arcs and angles and segments and where they are. Now let's practice some. Okay, so here is, first we are going to locate the vertex. The vertex is inside. So I know that it's arcs and angles, so I always start with my angle equals 1/2 and then arc plus arc. And that's how I set up my problem. So now all I need to do is plug in every piece. So my angle is x equals 1/2, and then you can add in any order, so it doesn't matter which order you add in. So I have 1/2 times, what is that, 252? And then I take 1/2 of 252 and I get 126. And that is my answer. Alright, next one. My vertex is outside. So I know that I start with my angle equals 1/2, and this is going to be arc minus arc. So I start with x, because that is my angle, equals 1/2. My bigger arc is 170. My smaller arc is 72. And your bigger arc is always going to be the outer one. Out minus this inner. So now, all I got to do is punch that into my calculator. So 0.5 times, and then parentheses, 170 minus 72. And I get 49. And that is my x value. Alright. These next two are a little bit more challenging. And the reason is because they just don't have all the parts. So if you see P and R are tangents, so you are going to have to take 360 and minus 232, because I know that this is 232, and this inner part is going to be the exact, if you add up the red and the blue, you're going to get 360. So if you subtract the two, then you get what's left, which would be your blue arc. So I get 128. So this is 128. Now you can easily set up your problem. This one also is a little bit tricky because you're not given the arc that matches up with your two angle, or you're not given the angle that matches up with your two arcs. So I know that 52 and this little x angle add up to 180. So I do 180 minus 52, and I get 128 again. Funny. 128. Now I can set up my problem. So in these two cases, it was a little bit tricky because you had to do something before you could set it up. So now, since it's all set up for you, I want you to actually go through and solve for x on these two problems. And then you can check your answers. So pause the video, and then we'll check. All right, here's your two problems. The first one, do you see I wrote down angle equals 1/2 times arc minus arc, because your vertex is outside the circle. Here's your vertex. It's outside the circle, it's Q. So then I just plugged in everything I needed. X is my angle, 1/2, and then 232 minus 128. And I just punched all that in my calculator, and I got 52. Now this one, so I have angle equals 1/2 arc plus arc, because my vertex, you see, is in the middle, inside the circle. So now my angle now is 128. It's not my x. Equals 1/2 times, and then your two arcs. So if I see my two arcs, it's going to be x and 144, and I add those two up. Divide by 1/2, which is the same as multiplying by 2, and then I just subtracted 144, and I get 112. All right, so those are all arcs and angles. These are segments. So I need to find ML and JK. So I know the vertex is inside the circle, so that means that I'm going to do part times part equals part times part. So that's my key, my equation. So part of it is 5 times 12 equals x times 6. So 5 times 12 is going to be 60 equals 6x. So I divide, and x is going to give me 10. So to get ML, if x is 10, I get 16. And JK, I already knew, was 17. And all I did to find that is I found the length of J and K, so 5 plus 12, and then I found the length of ML, which is 10 plus 6. All right, now when you come to a problem that has secant segments, what I want you to do is I want you to put brackets. If there is no brackets on the picture, I want you to put some brackets on, and you need to find the total. So if the inner part was 4 and the outer part is 6, 4 plus 6 is going to be 10. Now, the bottom part is not 5x, because you added 4 and 6. So the bottom one is 5 plus x plus 5. So you need to make sure that you add the two parts to get the whole, and you don't multiply them. So now if I look at my equation, out times whole equals out times whole. My outer part is 6, my whole part is 10, my outer part is 5, and my whole part is x plus 5. And now I just solve. So I get 60, 5x plus 25, so 40, 35 equals 5x. So then x would equal 7. And that's my answer. So there's some arcs and angles for you, and there's some segments. Now I have a few more here. I'm not going to do all of them. You can for sure do them. There'll be more practice on the homework. If you see a bracket there, like this one, you don't have to add an extra bracket. All you have to do is add this one. And 8 plus 4 is going to be 12. So I already know my whole is x on the top. So out times whole equals out times whole. So the outer piece is 3, the whole part is x, the outer part is 4, and the whole part is 12. So this is 3x equals 48. So do you see how this already had a bracket? So it showed me the total, so I didn't need to add up any parts. And then I just divided to get 16. And that would be my x value. Alright, we are going to try this one. So I'm putting in my brackets. Now if you have a tangent like RS is, your outer piece and the whole piece are going to be the same. Here your outer pieces, you're going to add up the whole thing, so x plus 7. So then it would be x plus 3 times x plus 3. And then you have your outer piece and you times it by the whole piece. So that would be x plus 7. Now you are going to distribute the x over here, and then here you're going to double distribute. You're going to FOIL it just like how you did in algebra. So it would be x squared plus 3x plus 3x plus 9 equals x squared plus 7x. Now I'm going to subtract x squared to get rid of that, and we don't have to worry about factoring. 6x plus 9 equals 7x, and then I subtract. And I get x equals 9. And then it said find RS. So RS is this piece right here. So that means all I have to do is do RS is 9 plus 3, and I get 12. Alrighty. So now let's do some practice problems.